In this lesson, we're going to have a look at the way we can calculate the distance of a line joining 2 points. Now there's two ways that we can do this. The first way is to actually use Pythagoras' theorem. Let's plot these points. This is 7 and minus 3. So here on the x-axis we go to 7 and then down to minus 3. And I'll just write that in there, 7 and minus 3. And the other one is 3 and 6. So there's 3 on the x-axis and then we go up to 6 on the y-axis. And we'll mark that one in as well, 3 and 6. And we'll join the lines together. So we'll go from here down to here. So the question is, how do we actually work out the length of that line? Now, if we create a right angle triangle by drawing a line down this way and a line across this way, and I'll mark in a 90 degree there, we can actually see or use Pythagoras' theorem to work this out. Now, Pythagoras' theorem, as you know, says that if you've got a right angle triangle like this, there it is there, and we'll call this A, we'll call this side B, and then we'll call this side C. A squared is equal to B squared plus C squared. Now we're actually trying to find that distance there, which we'll call A squared. The length of this line, you can count it if you like. There's the distance up this axis is from here right up to here is 6, because you can see there's the 6 there, and there's another 3 down here, you can see that there. So there's a total distance of 9 going down here. The y points, the difference between those y values tells you how long that line will be. So if you like, going from minus 3 up to 6 is a distance of 9 steps. So we can actually put in that A squared is equal to 9 squared, and then this distance along here, C, is done with the x-axis. And if you have a look here, there's x is 3, cuts at the x-axis, and if we go along to 7 on the x-axis, the jump is from 3 to 7, which is 4. So you can either count the jumps, 1, 2, 3, 1, 2, 3, 4 across to there, or along there is probably the easiest way to count it, 1, 2, 3, 4, or you could just take the jumps from the x value 3 to the x value 7, and that gives you the distance. So let's finish this using Pythagoras' theorem. 9 9s are 81, 4 4s are 16, and all we need to do now to finish this off is to add the distances. So we get 97 on this side, and to get rid of the A squared, we actually take the square root of both sides. I'll just write that up here, that one there and that one there. That works. So the square root of a square gives you the actual value A there. A is equal to the square root of 97. So if you work out the square root of 97 and we round it to 2 decimal places, you get the answer 9.85, and we'll just write next to here to 2 decimal places. So there's our distance, 9.85. That's using the Pythagoras formula to calculate the distance of that line. Now there is another way to do that, and that's using the formula, the distance formula, which is based on Pythagoras' theorem. If you look at it carefully, you can see there's the distance, there's the square root sign, and you'll see a square there and a square there, and these x's and y's depend on the x and y values up here. And even though we're not going to go into details in this lesson on how this came about, if you look at it carefully, you can see Pythagoras' theorem hidden away there. Now, to use the formula, the best thing to do is to first of all establish which are the x and y values. You'll notice there's a little x with a 2 here and an x with a 1 here. That simply is to tell you that there are two different x values, and we're calling one of them x1 and the other x2. And similarly with the y values, this is y1 and y2. Now, the critical thing is to make sure that you always use the same x1 and the same x2 right throughout this question. Now, we don't need that plus there. We'll just write in 3 and 6. They're the 2 points. What we need to do here is to label these points. Now, there's an x value. We're going to call this x1 because it's the first x value. And that means that this one over here we'll have to call x2. This one we're going to call y1. Now, you must match up the ones. So if this is going to be x1, that has to be y1. You can't use that as y2. The ones have got to be the same. That means that this one here would have to be y2. Once you've established that, and I'll just put a little line down here, once you've established which values are x1 and y1, the actual procedure isn't too difficult. You've just got to make sure you don't make any mistakes. So I'll put in x2 first of all, so we'll find it there, that's 3, minus, now x1 is 7, and we'll notice that that's squared. I haven't put the square root sign in, but I will shortly. And let's put in the y2 value, there it is, 6, and we need to subtract the y1 value. Now this is subtracting a minus 3, so I'm going to put the minus 3 here, and that will just remind you of the rule when you've got two minuses there, you're actually going to change that to a plus sign. Now we do need the square root sign to cover this whole formula, this whole side rather. Alright, so the distance is equal to, let's just keep that sign there. And we've got 3 take away 7. Now 3 take away 7 is minus 4. But we're going to square it, and we know that a minus times a minus is a positive, so it doesn't matter if it's a negative number, but we do need to write it in correctly. And here we've got 6, 2 minuses is a plus, so 6 plus 3 is 9, and we'll square that. Let's keep going, just about there. So that's minus 4 times minus 4, that gives me 16. And that's 9 times 9, and that's 81. So now we're back to a fairly simple solution to this. We add the 81 and we add that to 16, and we get the square root of 97. And when I find the square root of 97, as I did in the previous method, and round it, I get 9.85. Now that's going to be to 2 decimal places as well. So if we have a look at that answer and cut back to the previous question, 9.85, let's go back. There it is there, 9.85. Identical answers, different methods. But in fact, one is just using a formula. You'll notice in this particular question, we didn't even have to plot the points. There they are. This is the point 3 and 6, so I'll write it up here. And this is the point down here of 7 and minus 3. But in fact, using the formula, we didn't need to draw the line in and then draw up the right angle triangle. All we needed to do is to make sure that we put the x values and the y values correctly into the formula, and we had our solution.